Hello and welcome to the design and analysis of algorithms. The study of the design and analysis of algorithms can be covered or divided into two essential parts. As indicated in the title, the first part is the design of algorithms and the second part is the analysis of algorithms. We strongly feel that the emphasis on these two parts, the design and the analysis, is the most convenient way to organize the study of the subject. So let's talk briefly about these two parts. The first part is the design of algorithms. It is defined as the process of developing and writing efficient algorithms. You know that writing an algorithm is an art that can never be fully automated. However, to help you master this art, we will teach you various design techniques that have been proven in the computer science literature to be useful and often produce good algorithms. Some of these design techniques are brute force, divide and conquer, greedy techniques, dynamic programming, and others. Now for the second part, which is the analysis of algorithms. It is defined as the process of measuring the performance or efficiency of algorithms. This is a very challenging area which requires a great mathematical skills. In fact, there are two kinds of algorithm efficiency. Time efficiency, indicating how fast the algorithm runs, and space efficiency, indicating how much extra memory it uses. In the early days of computing, both resources, time and space, were extremely important. And nowadays, on one hand, the amount of extra space required by an algorithm is typically not much of concern. But on the other hand, measuring time complexity of an algorithm is still a requirement for developing efficient algorithms. Therefore, we will be focusing more on measuring time efficiency, although for some problems, measuring space efficiency is really a serious issue that needs to be taken into consideration. That's just a brief introduction on what we will cover and discuss in this subject. But before we embark or start the discussion and exploration of the design techniques and their analysis, we need to know first how to write an algorithm without having prior knowledge on any design techniques or strategies. An algorithm is a sequence of unambiguous instructions for solving a problem. For obtaining a required output for any legitimate input in a finite amount of time. Now, if we look to the definition, the reference to instructions implies that there is something or someone understands and follows the instructions given. So who we are writing the instructions for? So basically, we are writing the instructions for the computer to follow. And also, the meaning of unambiguous is that each operation must be definite and also perfectly clear. As an example, add 7 to x or go to line 3. But instructions such as add 6 or 7 to x is not clear because it's not clear which number to add to x. Is it 6 or 7? So the definition can be illustrated by the following diagram. It starts with the problem, followed by writing the instructions to solve this problem, which is the algorithm, followed by writing a computer program for the computer to follow the instructions of the algorithm. As illustrated that all algorithms must have an input, which is a 0 or more quantities that are externally supplied, and also must have an output, which is at least one quantity produced by the algorithm. To illustrate the notion of algorithm, we will present some examples for solving some problems, considering different methods and ideas for these problems. In particular, in these examples, we will show you how to specify the input for these problems and how the same problem be represented in several different ways. And also we will show you how several algorithms solving the same problem may exist. And finally, we will show you how these algorithms have different ideas and different speeds.